In science, things are either likely or unlikely. That's it. That's as far as you go. And if they're very, very likely, for example, it's extremely likely that tomorrow morning the sun will rise, um, based on everything I know. And I'd say, therefore, you might say the science is settled in that regard. The questions of science are often different than public policy. So, from a scientific perspective, the fact that vaccines work is 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 more or less settled science to the extent that it's extremely likely based on everything we know. Whether it's appropriate to use them in certain contexts or require them in certain contexts is a public policy issue, and an informed public should ultimately make that decision. But they should be informed. I don't think of any absolute morality because it's a human concept. There's not, and humans are just a side event in the cosmos, not particularly important. And when we're gone, no one will notice. It seems to me that the fact that sea level, that was one of the things that first got me involved when I was chairman of the board of the Bolton Atomic Scientists. We did the doomsday clock, and I heard from climate scientists for years. I had no idea that sea levels had changed by tens of meters over recorded history. When I learned that, I thought, well, maybe one should look at this because maybe this is an issue that might be relevant. Because a meter is one thing, but changing by 120 meters is another thing, and it's happened. Now, the difference between the time of the dinosaurs is that we didn't have civilizations and economies and agriculture and cities, coastal cities. And so we have to ask, what is the effect on modern humans? Not would the world be a much better place if there were gigantic plants and big dinosaurs?
I'm honored today to have with us Lawrence Krauss, professor, theoretical physicist, and I'm sure he's more than a physicist theoretically. He has exhibited kind of what I consider a boundless curiosity, but he'll be able to tell us what the bounds of nature are and whether there are any bounds to curiosity. He's seems to be peripatetic and tireless. He has his own series of videos and uncovers a lot of, I guess, well, I don't know, discovers, uncovers, recovers, or just covers in general a lot of science and brings things palatable to the populace. And I respect him for that. He's been brave enough to have on my near classmate, Heather MacDonald, perhaps the best investigative reporter in the U.S., extant. And Professor Krauss, thank you for coming on. And I don't know, any initial thoughts, or we could start with the big one. How did we get something from nothing?
Well, I wrote a whole book about that one. So well, look, it's nice to be on. I'm happy to counter any misconceptions about the world, and it was a pleasure to have Heather on, who I guess was your classmate at Yale, and although she, I think, probably did music or literature, but anyway, she's a bit, as you know, English, yeah, which is the big degree at Yale.
Which she speaks quite well, I have to say.
Yeah, she speaks English very well. But you were physics and chemistry, you told me just before came on, which put you in the minority at Yale. When I taught there, it was largely English and history majors with a few scientists interspersed, sort of to like salt or pepper. But why is there something rather than nothing? Because well, first of all, if there's nothing, you and I wouldn't be here to have this conversation. And secondly,
we're meeting each other through nothing, unless there's an ether, which there isn't.
Not quite through nothing. That's the point. There's not, well, as you may know if you ever looked at my book, nothing is a subtle concept. Some people don't like the fact that science has changed what we mean by nothing, and a lot of theologians, particularly and some philosophers, don't like the fact that science has shown that there's really not a lot of difference between nothing and something. In fact, nothing is often unstable, and you have to get something. And certainly, things can come out of nothing all the time. In fact, in quantum mechanics, there are virtual particles popping in and out of empty space every second. They disappear again before you can see them. But it may sound like angels on the head of a pin. But while we can't see them directly, they have an effect on atoms, and an effect that we can calculate. And their effect is calculable to 13 decimal places and get the right answer. It's the best measurement in all of science of a theoretical prediction compared to an observation. So we know that virtual particles are out there, and the fact that they can pop in and out of empty space means what we mean by empty space even changes. So the whole concept is quite different, and some people don't like it. But as I often say, that changing definitions is what we call learning, and it's okay to change your mind.
That's an interesting point. The answer to every question is it depends. And so the answer to maybe, or my response would be to, change definitions is it depends. I mean, you don't want this kind of the Stalinist, ablation from history. And I think we saw during COVID, the changing of quote unquote herd immunity. And we changed what the concept of a vaccination was. Heretofore had only been prior, like prophylaxis, and then afterwards vaccination after you've gotten an illness. And herd immunity was, changed to be, inferior to vaccine immunity. And then the whole concept of what is pro-vax or anti-vax changed. So a lot of these things can be kind of social science experiments instead of just science experiments.
Well, when science is applied to society, it becomes much more murky. Certainly, the fact that vaccines work isn't so murky. The question is, it's always, and that becomes a public policy question: is risk versus benefits, freedoms versus restrictions, and my wife, who used to work for the government of Australia, often told me that she interfaced between scientists and politicians, and the questions of interest of scientists are different than the questions of interest of politicians, and the solutions are sometimes different. So sometimes it's an obvious scientific answer to something may not be the political answer to something, and one has to understand that that there are other issues, but besides what works. Sometimes in science it's just what works. That's all
Exactly.
that matters.
Exactly. And then, so let's get, further into definitions. What determines what works in science?
And what survives the test of experiment. That's it.
Fair enough.
What leads, and as a theorist, what survives the test of experiment and then leads to productive questions that allow you to further explore nature. But ultimately, it's experiment that's the arbiter. It's beautiful ideas. Elegance doesn't matter. The question is does nature respect it? But the ideas that really thrive are the ones that not only survive tests of experiment, but add insights that lead you to new questions, which allow you to understand nature, to make further tests and understand nature more deeply.
I agree with that. So getting kind of the social experiment. So we've proved it. We've proved something that I agree with you. So that's is that science?
Yeah. Well, at least on that, we'll see.
Yeah.
Okay.
So, in the realm of certain, aspects of experimentation, it's often hard to do things on a personal basis and on a human basis and so forth, because we can't run counterfactual examples of ourselves. We can't roll time backwards and so forth. And then there's also the kind of the scientific / political question of who's the observer bias. I mean, on a, kind of physics basis, we, think of, Heisenberg's uncertainty and Schrodinger's cat, all that kind of stuff, whether observation changes the event and so forth. But I think on a human basis, there's a lot of kind of filtration and I don't want to say groupthink, but, there are kind of brushing forces or wind under people's sails in terms of funding and so forth, that things that keep them physically alive, which is kind of a nice thing to be, as far as we know.
Look, I mean, science is a human activity, but the great thing about science itself is I was going to say it's been designed, but I think it was more accident. But nevertheless, it's a process, and it's a process that works to overcome the innate human biases. So scientists are human, which is a secret some people don't realize, and they're driven by lots of things, and including there's so many self-interest, and they're easy to delude themselves. But the great thing about science itself, the process, is it's built to be able to overcome those things eventually, and overcome the desire to want to believe, for example, which everyone does, and that process allows us to move forward in spite of the vicissitudes of society and scientists.
Yeah. So with certain things, though, it becomes contentious when science rubs up against public policy.
And that's a big, I mean, not always contentious, but it becomes murkier. And someone who's been interested in that interface, I understand that. Yeah.
So I think maybe we'll kind of, quote unquote, circle back to that later. But I'd like to kind of talk some more about or begin with cosmology, because at the beginning there was the beginning. And so we'll begin our video with some of your thoughts on the cosmological aspects and how they intersect with our kind of perceptual divinity needs and aspirations and so forth. And where does one parse these things and kind of draw the line? And since you've written on the topic, maybe you can just give a quick exegesis.
Well,
Some of those
I
thoughts.
mean, the whole point of science is that there's no need for God. I mean, there's no need for divinity. Science is based on the premise that generally physical effects have physical causes, and we haven't yet found that not to be true. And so, while for some people the notion of science and God seems to be important, when it comes to scientists, as a scientist for over 40 years working, I never heard the word God mentioned once in a science seminar or meeting. It's just irrelevant because it doesn't matter. We want to know how things work and learn about how the universe works. And the why question, as both I and Richard Dawkins have argued, is often meaningless because it presumes purpose. But there doesn't need to be purpose. It presumes purpose. So in any case, there's no need for God. Science doesn't disprove God. It certainly disproves much of the miracles, many of the miracles of the standard world's religions, which are inconsistent. Their stories are inconsistent with what we know about. Their stories taken literally are inconsistent with what we know about the universe. But it's not that science works to disprove God. It just doesn't need God.
Well, humans might. I mean,
Humans haven't. There's no doubt that from an evolutionary perspective, from a perspective of evolutionary psychology, humans seem to need something like religion. That's why it's ubiquitous. But that doesn't make it true.
No. There's kind of a truth, kind of the human soul, which I think it's difficult to measure. I don't know if anybody's ever weighed it.
Well, there's no evidence of a human soul, so I guess I would say that that's um, um, an interesting concept that has no scientific validity at this point.
No, I understand that. Then, as I mean, we don't necessarily need to stay in the sphere, but a lot of morality, laws, and so forth. How does say a scientist kind of square those circles of laws being kind of having a moral application? And is morality innate, and does it come somewhere out of the juxtaposition of science, or is it really kind of an interplay of evolutionary forces and how tribes or animals or packs group together and mete out their own justice in a sense?
Yeah, I think morality is certainly evolutionarily based. Again, I don't think of any absolute morality because it's a human concept. There's not, and humans are just a side event in the cosmos, not particularly important. And when we're gone, no one will notice. But I think morality is contextual often and societally based. Nevertheless, the progress of science has, however, changed, I think, our views of morality, because while I agree with the famous statement, I think that you can't get an ought from an is, which I think is David Hume. An is takes you pretty damn far, because until you know how the universe works and what the consequences of actions are, and that's what science is all about, then you can't decide whether those actions are reasonable or not. And so I would say without reason, morality doesn't make sense. And without reason, experiment, observation, and experience.
All right. So you have an origins series. Like, why did you name it that way? And how do origins relate to you, and why are they important to you?
Well, there are a variety of rationales for why we named it that way, but I think the main thing is that progress at the forefront of science, but I think of almost any intellectual activity, but science in particular, is often intimately related to origins in one way or another. That to understand exactly how we've got to where we there's often an intimate relationship with origins. And so from an intellectual perspective, it seemed useful. Now, my own research is often related to the origin of the universe, so obviously that's a personal perspective, but it's more than that. It's also, so it really is that the forefront and the beginnings are really the same. There's one of my favorite quotes that I used in one of my books, that Louise Bogan's, that says something like, the most interesting thing in any mystery is how the traveler got to the starting point in the first place. And but I also take that literally. I also like to, when I'm talking to people, to understand how they got to where they are. And if I'm talking to them, there's some reason they've had some impact on the world, and I want to know how they got there. And also because I think science is too often divorced from culture, which I don't think it should be because it's an integral part of our culture. Going back and looking at people's origins helps me connect science and culture.
I don't know if you feel comfortable talking about yourself and your own origins, but how did you wind up in that chair right there doing the things that you're doing? A, the science journey, professorship, physics, experimentation, and then B, kind of the meta-analysis there over the kind of the rehashing or explaining science to others.
Well, a series of long accidents, I think. Ultimately, I didn't have some cosmic plan. Well, I mean, there are things I wanted to do, and I've been lucky enough to do a number of them. I grew up. My mother wanted me to be a doctor and my brother to be a lawyer.
Oh, that's what my mom got.
Yeah, my brother became a lawyer, and it made it even more.
I have a lawyer brother and a previously wannabe lawyer brother. Went to law school, didn't make it, and he became he kind of was before and after a journalist, whatever that is. And
well, my brother did the opposite. He did a lawyer plus because then he became a professor of law.
Oh, he could have become a doctor and satisfied both.
Yeah, well, my mother was for a long time when I got my first job at Harvard, she was very disappointed that I wasn't. And she told my wife at the time that I could still go to medical school. So anyway, but because my mother wanted me to be a doctor, I think that probably influenced me. But I got interested in science very early on, and I kind of fell in love with science. I remember reading a book when I was a young kid about Galileo, and that had an impact on me. And so I always thought I would want to be a scientist, but at the same time, science seemed a little removed from humanity, and I've always been coupled to humans, either politically or otherwise. And so I toyed with doing history for a long time, and I actually took time off college to work on a history book. But ultimately, the fundamental questions of trying to be the first one to understand some feature of the universe just seemed too seductive to me. And there were heroes along the way, not just Galileo, but then when I read books by Einstein and then Richard Feynman and other people that influenced me. So I eventually went back to school to do my PhD in physics at the time without a real expectation of getting a job. But physics and particle physics in particular for me was the sexiest thing because it was the fundamental questions. And then I got interested in the interface between physics and cosmology because the universe is an experiment and it's now just data analysis. But at the time when big accelerators were not getting results, it became clear that the universe could be a way to test our ideas. Anyway, but during that time, I've always been interested in public exposition. I worked as a young person in a science museum, and I always loved people like Jacob Bronowski, and I was always enamored by scientists who wrote Feynman, but Einstein, Gamow, even Asimov. And I guess I thought that was a neat thing to do. And later on, when it was reading books by people like that really got me interested in being a scientist. But the Feynman books in particular, I think, that I later on decided to return the favor by writing. But also I've been interested in writing because I've done history. And then one thing led to another. I mean, because of some success there, I had exposure outside academia and the public and in newspapers and then ultimately in films. And, it's just been one thing after another. So I've had this opportunity to straddle a number of worlds, and that's a great gift that I don't take lightly.
No, I appreciate that. That's a wonderful thing. Richard Feynman, I never overlapped with. I never got to meet him, but obviously there's some great stories and videos and so forth. Did you ever get to meet him?
See that little picture behind me? That's me and Richard Feynman.
Well, there you go.
Person. Anyway, yeah, of course I did. I wrote a book about him, by the way. So, and yeah, I talk about that in there, a scientific biography of Richard Feynman. But yeah, I met him when I was in university and got to know him.
Yeah. And what was so for the uninitiated out in the audience? How would you express Richard Feynman, and what do you think he kind of brought to the table for physics?
Oh well, I mean, he was brilliant, and he had major impacts in the field, but also as an educator. I mean, he had this charm and charisma and humor and being down to earth that was intoxicating. And as I say, I think I I thought of him as a role model in some ways in terms of trying to relate to people and explain things. So he had this dual role of being brilliant and having played a major role in understanding one of the four fundamental forces in nature and the way quantum mechanics works at a fundamental scale. He did a lot of other things, and as I say in my scientific biography of him, I talk about them. But he also affected a generation or two of young scientists by his approach, which is always empirically based, questioning, but also his joy and immense pleasure at finding things out, which is the title I think of one of his books. Uh, and he wrote he gave a series of lectures at Caltech, which then became called the Feynman Lectures in Physics, and all physics students kind of carried them around like the Bible for a while. I still have many copies of them actually, and so but I think it really was his desire, his intellectual honesty, and his desire to question and not be fooled, um, combined with a joy of discovery that I think certainly affected me anyway, and affected the way I try and interact with others.
Yeah, I can see that. On some level, I once heard that every web page, every video game is a spreadsheet. That everything kind of comes down to these kind of topological relationships. You're on some meta hyperspace where there are interactions. So if somebody's playing World of Warcraft and he wants to pick up a sword or not, or he's going to go for the the maiden in distress, that's a decision branch, and it has to be weighted, and there has to be kind of an application, and ditto kind of everything else we do. Does physics? I mean, I was attracted to physics, not necessarily electrostatically, but kind of on an Occam's razor kind of theoretical way. I was kind of a math guy, and
I mean, most doctors, by the way, were forced to take physics as pre-meds, and that's the last exposure they had to it. So I'm glad to see.
I loved it. I would have gone the other way. I don't know if we had the same mother. I don't think we're related. There's maybe somewhere back in
one sense we all are, but anyway.
Yeah, but in the past, my mom wanted a doctor, and every kind of thing I suggested along the way, I came up with doctor on my own as a kid because I had an injury that got miraculously, I can't use the word miracle, but very amazingly fixed, and I aspired to be a doctor after that. That was a young age. And every time I decided to be a fireman and an astronaut, it was always, well, you forgot the doctor part. Anyway, so along the way, I might have done more sciencey kind of stuff, but the doctor stuff interested. But as far as like it's a hierarchy, there's say mathematics, then physics, then chemistry, then I don't know what, maybe biochemistry or whatever, and then biology, and you kind of move down the realm to whatever they call. I always kind of object when they call political science, social science.
Yeah, I know. It's aspiring science, but at its best.
So I'll try to pop a question here. Literally, what is science? I mean, I have my own thought about it. I kind of think there are two definitions. But what do you consider to be science, and how which of those things are sciences, and which of them aspire to science, which actually practice?
Well, I think, as I say, science is a process. That's all it is. It's a process for separating what is likely to be correct from what is likely to be incorrect, and it's a methodology that relies on ideas that are tested and then retested and retested and reformed and reshaped and subject to attack from the community, which is really important. Science is a social activity; it's not done individually, and you put your ideas out to be attacked, and the ones that survive are the ones that survive. And this process, this dialectic of individuals and dialectic that compares theory and experiment, eventually refines things. And in the way of Sherlock Holmes, it's not that it seeks truth ultimately, because there's no such thing as ultimate truth in science. It's always contextual in some way, but it separates that which isn't been ruled out is maybe correct, and that's
Yeah.
basically what science
That's
is.
actually a great quote. I use a quote in my book. It's from Silver Blaze, the dog that didn't bark in the night. I'm sure
Yeah,
you know that one.
yeah,
And I think Lestrade, or maybe it's Lestrade. I'm not sure how they pronounce it there. You know, he says, "What about the dog that didn't bark? What there wasn't he didn't bark in the night." Well, that's the point. Sometimes the absence of something is a presence, like the fact. In the case, it turns out the fact that dog didn't bark meant the intruder was known to the dog. So
yeah,
there's a piece of information. It's kind of like the Monty Hall um,
yeah.
paradox, right?
Which always seems, even when I do it, it always seems so the solution seems so non-intuitive. It's really kind of amazing, but it is Sherlock Holmes. It's just a matter of sifting out what may be true by getting rid of all the things that aren't, and
Yeah, that's
eventually proven whether you like it or not. And that's the other thing. Well, in Sherlock Holmes, I'm not sure it's always the case, but I think even Sherlock Holmes would be that way. It's driven to a reality that may not be the one you want.
right.
That's the key point.
Yeah,
That science takes you places where you may not want to go, and what nature doesn't give a damn what you want. And so the great thing about science, I think, is being proved wrong because it's very liberating.
yeah. It also can be embarrassing. I think the sort of the interaction between humans and reality. I mean, we can call that kind of our consciousness and sometimes God and whatnot. But the interaction between humans and their fallibilities, I mean, that's an interesting place. And insofar as we can be scientific observers, that's a nice thing. But I think it disappears, when people want science to be more than it is. I mean, I think, I don't know how you feel about trust the science or the science is settled. I mean, that one phrase always kind of stuck with me.
Science is never
When people say the science is settled, what do you feel about that?
Well, look, it's a statement that I understand where it's coming from. And it's like saying belief, which is another thing we don't use in science. If saying the science is settled means, in general, I think means that it's something is overwhelmingly likely based on in science things are either likely or unlikely. That's it. That's as far as you go. And if they're very, very likely, for example, it's extremely likely that tomorrow morning the sun will rise. Um, Based on everything I know. And I'd say, therefore, you might say the science is settled in that regard. But there's new things we'll learn at the edge of science that are always changing the nature of science. But what people don't realize is just because science, we don't know everything, doesn't mean we don't know anything. So that which is, first of all, what we do know is that which is not satisfied the test of experiment is not true and will never be true. And so once something, fails the test of experiment, we throw it out like yesterday's newspaper. But and we do know on that basis that we know a lot. We know if I take a ball here, no matter what I learn about quantum gravity, if I take a ball and let it go, it's not going to fall up. Just the way it is. And so it is true that there are lots of things we don't know. And when it comes to medicine and epidemiology and other things, it's harder to have more unimpeachable claims, but nevertheless, there are things we know. And for example, I think let me put it this way: I think we know the science has settled that vaccines work in general. That vaccines work; they build immunity, and they have saved thousands, countless millions of lives over the years.
Yeah, I've given out personally. I've given out thousands of vaccines to my patients over the years. But the question then becomes about which. Like, I believe in clothing. I think clothing. You and I, from what I can tell, are both wearing clothing, unless that's painted on.
I don't use the word belief. Let me make that quite clear. Things are likely or unlikely. Believe is something
Okay.
as a term that I sometimes use it, but I try and censor myself when I do because I don't think it has any meaning.
Well, fair enough. So my point is, I find clothing has utility in keeping our body warmth in, and or modesty issues or social stratification, whatever. There's a lot of use for clothing, but I don't wear every bit of clothing to the beach.
Yeah,
I don't wear my my little I don't know, YMCA kind of bikini swimsuit to a board meeting,
yeah.
and nor do I wear it if it's going to be freezing outside. So the fact that vaccines work, clothing works. The question is how much of it you need and for which circumstance.
But that's a public policy question, not a science. So I said that questions of science are often different than public policy. So from a scientific perspective, the fact that vaccines work is more or less settled science to the extent that it's extremely likely based on everything we know. Whether it's appropriate to use them in certain contexts or require them in certain contexts is a public policy issue, and an informed public should ultimately make that decision. But they should be informed.
You're
Now,
right.
it's hard to be informed in the middle of a pandemic when something's new, and I'll tell you right now, I believe that given what was known and given the risks that were inherent, I think it was not inappropriate to require vaccinations.
To a point. To a point. I've spent a lot of time on this topic, and I kind of did my own fireside chat when there was very little else to do during the deep
Yeah,
dark. The concepts of public health that were being applied at the time were not appropriate. Lockdowns heretofore had never been used, except I think in Freetown, oxymoronically named Freetown,
yeah,
Sierra Leone, during an Ebola episode, and during some piece of South Africa. Some prisons were locked down for kind of antibiotic-resistant tuberculosis, but lockdown was a term of art only in the prisons. It had never been used in the public health sense. And to bring that out, and I think they also, a lot of science depends on which, where you look and what the facts are. There's old joke about, or parable about the guy looking under the street light for his car keys.
yeah.
People look in the convenient place, and
Yeah.
there's sins of commission, there's sins of omission. I think that Dr. Fauci knew very well that Diamond Princess had data that showed people get sick from this, but the people who got sick from it were elderly. And the young people really didn't experience it at all. The middle-aged people might have had, sniffles and a cold, but didn't really slow their ride down very much. And there were a lot of naval ships and so forth out in the
But I have to look. I realize, and I accept the argument. Also, since I know some of these people now, that herd immunity there's issues that made that advantageous. But what I do remember vividly is hospitals being overrun and overwhelmed with patients that they couldn't handle, and that was getting worse. And that's a public health emergency, and how you deal with it at the time,
well, it's
especially
to a
if you
point.
don't know the
Yeah,
answer. What you sometimes do when you don't know the answer is you take when you can't assess the risks, is you kind of assume the worst and see how you can
I
protect.
understand that, but that's sort of similar to having your CO2 or your heat measures in the middle of an asphalt parking lot. New York City is not Kalamazoo. New York City, this unfortunately or fortunately, whatever, the thing landed in New York City, which has its own set of preconceptions, has the New York Times, has Donald McNeil, has a bunch of things going for it that give it kind of an observer bias. And then it happened in Queens, which is the single most polyglot, atomized place on earth, possibly. I think there are 430 different, dialects and languages extant in Queens at the time. And those hospitals may have been, quote unquote, overrun temporarily, but that didn't actually replicate through the populace and so forth. But I don't know, we can stick on this a little bit. I understand, made and they're factors of time.
It seemed to me even in Oregon that the local hospitals were being overwhelmed. But anyway.
Well, we can go back on that. I don't know if it's best use of our time right here, but since we're kind of like maybe taking the gloves off a little bit, I along the lines of political science and social science, there's climate science, and I've always thought, I would love to make money by predicting the winner of the Super Bowl 10 years hence. I think it'd be a great play if I could tell you the score, if I could tell you who's playing, who's going to be the MVP. But the MVP of Super Bowl 10 years from now it might very well be in middle school or something like that at this moment, and God knows whether they're going to be playing it here on Mars or whatever. And we there's a lot of variables. Whether they use the same size football or they go backwards. Who knows? So to do that would be kind of predictive data analysis. I would be able to take a lot of data points based on what I see that, Patrick Mahomes seems to be a kind of winning thing. Find the next Patrick Mahomes, find the next, Bill Belichick or Andy Reid, or whatever, and prototype that out and play it out. And if I did that, I'd make a fortune. Now, a fair amount of science has to be kind of an experimental method and things that we can actually, play with and experiment with. And I think there's a concept of begging the question, or petitio principii, where a lot of people make these assumptions about certain things, kind of post hoc reasoning for things that are going on, and then they make assumptions thereof.
Well, look, I mean, predicting football is a lot more complicated than, say, predicting the long-term future of the universe, which is why I spend my time trying to predict the long-term future of the universe. It's much simpler.
You took the easy route.
I take the easy stuff. I tell people that's why I didn't do biology. Physics is so much easier. Uh, but and correlation isn't causation. But what people don't realize is that when it comes to say climate science, and that's why I wrote a book called The Physics of Climate Change, it's fundamental physics. So it's not something exotic or even forefront science, at least at its basis. It's fundamental
Yeah.
thermodynamics, and has been tested over and over again for 150 years. So if there was just a correlation, say between CO2 and temperature, or sea level, I would be dubious. But the point is, when there's a fundamental physical explanation, which there isn't in football, as far as I know, at least when it comes to human behavior, it's too complicated. But when it comes to the fundamental understanding of the fact that energy in equals energy out means things don't change, more
Mhm.
energy in than energy out means things heat up, more energy out than energy in means things cool down. That's pretty basic stuff. And when you can actually measure the excess energy that's coming in compared to what's going out, which we can do, and then plug it in some fundamental equations in physics, which have been around for over 100 years. The fact that hot bodies radiate as the fourth power of temperature, for example,
Yeah.
and make predictions that agree with observations, then I think it's fair to say that's has a very good basis in science. Now, there are details that are incredibly complicated that require computer models to know about ocean currents and other things. But knowing, for example, that about between 1 and 2.5 watts per square meter of excess heat is being stored in the earth due to the presence of carbon dioxide in the atmosphere, that's just fundamental science. The fact that if you make a global prediction of what that would do to the rough temperature of the earth, that would go up by about a degree to a degree and a half over the last 60 years, which is in agreement with what we observe, tells you that, okay, I think that's pretty soundly based. The fact that water expands when it gets hotter is something that you learned in high school, probably. And the fact that we can ask how much heat we have dumped in the Earth's oceans over the last 40 years, and we can say, independent of glacier melting or any of that stuff, that just simply the heat dumped in the oceans when it thermalizes will cause the oceans to rise about a quarter of a meter over the next 20 to 30 years minimum. That's fundamental stuff, and I think that's unimpeachable. If you want to call it settled, you can call it that. But so there are other details. There are worries about Greenland and worries about ocean currents, that may affect Europe, and droughts here and there, and all of that are more refined questions. But fundamental science tells us that that the Earth is heating up due to the presence of increased carbon dioxide in the atmosphere. I think that's pretty well unimpeachable. The fact that ocean levels will rise at some level, as I say, somewhere between a quarter of a meter and a meter this century, is also unimpeachable. And that alone tells us we should at least think about how to address the issue, even if it's adaptive, to ameliorate conditions of the 700 or 800 million people who live less than 1 meter above sea level.
Fair enough. So let me ask you a couple of things based on that. First of all, Henry's law is that it's kind of, we all know what Henry's law is when we have a warm bottle of soda or something like that. You open the thing and the CO2 literally sprays out of the bottle. Colder temperatures, ironically, are inimical to what happens with solids.
Well, let's get back a little bit, because this is an example I like to use in class. But carbonic acid is the reason that soap bottles spray out is that under high pressure you can dissolve carbon dioxide in water and make carbonic acid. When the pressure is released, you can store less of it, and that's why soda fizzes, and carbonic acid tastes tart, and that's why sodas are tart when you first open them up. After a while, when the carbon dioxide is gone, the tartness is gone because the carbonic acid is gone. So it's part of basic chemistry. But anyway, sorry, go on.
Yeah. So the question I have is kind of like chicken and egg. And everyone assumes that CO2 is kind of levels increase is man-made. We didn't make the fossils that form fossil fuels, so they're at one point they're out in the atmosphere and more carbon-based forms. So then a lot of them kind of absorbed, subsumed in the.
There were times in the Earth when the carbon level was much higher and the temperature was much higher. That's right.
Right. And also,
By the way, there were times when sea levels were 100 meters less than they are now, and they're
there's also times when there were more. I mean, you wouldn't have the Grand Canyon and some of the excrescences or whatever you want to call them in the West if they weren't underwater at the time. I think the Bonneville Ocean or whatever it's called.
But this should all cause us um, this should all cause us some concern. It seems to me that the fact that sea level that was one of the things that first got me involved when I was chairman of the board of the Bolton Atomic Scientists. We did the doomsday clock, and I heard from climate scientists for years. I had no idea that sea levels had changed by tens of meters over recorded history. When I learned that, I thought, well, maybe one should look at this because maybe this is an issue that might be relevant. Because a meter is one thing, but changing by 120 meters is another thing, and it's happened. It's happened over periods of a few thousand years in Earth's history.
Right. Yeah. So the point I was going to make is chicken and egg. If Henry's law dictates that there's going to be less CO2 dissolvable in a body of water as temperature goes up. So what if that it's not really man-made per se, but let's say that the sun got a little hotter because of whatever's going on in the sun. There's more energy absorbed. The temperature of the oceans go up slightly, and they release CO2.
They also release water. It's what happened what we used to think happened with Venus, and what will happen to the Earth in 2 billion years when there will be a runaway greenhouse effect because the sun will be 15% warmer and the oceans will evaporate, and water is a very big greenhouse gas, and that will produce a cycle that will eventually produce temperatures on the Earth in 2 billion years that are similar to those of Venus now, 700 degrees Celsius.
Right. So how much is Henry's law brought up in the fact that maybe CO2 is a result of independent warming, on a solar basis, the oceans, rather than vice versa?
Here's why. Okay, and again, it's in my book. It's if it walks like a duck and quacks like a duck, it's probably a duck. You can ask how much CO2 have humans been producing every year for the last, say, 70 years? 10 gigatons per year of carbon. Okay, not carbon dioxide, 40 gigatons of carbon dioxide, roughly. But 10 gigatons per year, every year, year in and year out. We also know the CO2 abundance in 1900 is about 600 gigatons in the atmosphere. Okay, you can ask how much have we put in? Well, we can also show from experiments that about 50% of the CO2 that we put in the atmosphere stays there. 50% goes in the ocean, deep ocean, and some in the earth. So 5 gigatons per year of carbon we have been producing by human industrial activity. And isn't it interesting that the amount by which the carbon dioxide in the atmosphere has increased is more or less exactly the number of years times 5 gigatons per year? And so,
well, that's not.
Hold on.
Obviously, that's not
conspiracy. Maybe there's some weird conspiracy that somehow cancels out the amounts we produce and puts it somewhere else, and some other thing has the source of it. But gee whiz, we produce this amount. That we know how much stays in the atmosphere if you produce that amount. That's exactly the amount by which the atmosphere is increased in carbon dioxide. I think you'd have to find a pretty compelling counterexample or
okay, so let me ask you, when there is an increasing CO2 level and potentially slightly higher temperature, is there a reaction on Earth by the photosynthetic, our little green friends, algae and trees and plants and so forth? Do they grow more? Is there more biomass and absorption of quote unquote?
There is, and you can take all of that into account. This is science. These people do this for a living because they want to try and understand the answer, not because they make more money if the Earth heats up. But and so and there were times when there was a lot more when the Earth was a lot hotter and there was a lot more biomass, if you want to call it that. Large plants, large amounts of carbon dioxide affect that. But that's irrelevant to today in the sense that, yes, that's happened in Earth's history. But what's happening now is that we're producing carbon dioxide and it's staying in the atmosphere at a rate that is exactly what you'd expect. It is having more or less the effect you would expect it to have, and it's going to have some consequences. Now, the difference between the time of the dinosaurs is that we didn't have civilizations and economies and agriculture and cities, coastal cities. And so we have to ask, what is the effect on modern humans? Not would the world be a much better place if there were gigantic plants and big dinosaurs? That may be true. But what really matters now is, say, when I was in the Mekong Delta in Vietnam, where almost all of Vietnam is less than 1 meter above sea level, will it affect the economics and livelihood and housing of the people in Vietnam when the Mekong Delta, which is the richest rice producing region in the world, is overcome by the salt water from the rising sea level of the nearby sea that is currently kept out by the Mekong, and those rice groves turn into mangrove swamps, and 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 will the people who once had homes and that don't have homes, will they become climate refugees, and will there be geopolitical consequences? These are the kind of questions we have to at least ask if we're interested in addressing, or as a biologist, Louis Pasteur once said, "Fortune favors the prepared mind," and
Mhm.
so it's worth asking yourself
The
the
Boy
question,
Scouts.
what might happen, so that we can proactively begin to address at least some possible consequences. But I think we do understand that, yes, increased carbon dioxide does produce more biomass. Great. And there'll be parts of the world, like where I live in Canada, well, not where I live, but in mid-level northern Canada, that will be much better for agriculture than it is now. So there's no doubt that there will be that changing climates will have some positive impacts in certain places. But we need to understand it carefully, because it can in principle have devastating consequences, global consequences, and
Right.
we at least have to explore those. And that means doing science. That means doing experiments, plugging in the best models you have, and trying to ask what range of predictions result. And that means putting in every bit, including biomass, including clouds, including this and that, to try and make your models as good as possible. And all the climate scientists I know are doing just that. They're trying to improve their models. They're trying to make them
But
stochastic. They're trying to ask for the variability so that the predictions include the uncertainties, which is really what people don't realize about science is that uncertainty is perhaps the most important part of science. Science is the only part of human activity where we quantify our uncertainties. So the fact that things are uncertain is not a weakness in science, it's a strength. And being able to quantify our uncertainties is the greatest gift that science perhaps gives humanity. And so when we do it right, we can quantify what likelihoods are of ranges of certain things. And that's what the people I know who are working in this area try
I
and do.
understand that, getting back to kind of first principles, when you keep saying science, I still think it's kind of modeling and predictive data analytics, and so that
Well,
I'm all good with that. But again, it kind of brings back to the sports
that
analogy.
social science. It's not just social science. It's not just.
No, I'm not saying it's social science at all.
I mean,
I think
there's
people.
fundamental science behind it. It's not just plugging in phenomenological models of what's going on. It's putting in fundamental physics and chemistry in there
I'm,
as
I'm
well.
not I'm not doubting any of that. But and again, to keep my sports analogy alive, if I were a decent I don't know, bookie or guy playing DraftKings or whatever, I would want the best data. I would want the best data. I want analytics. I want to know exactly the guy's height and his shoe size and how much he jumps when I'm doing the draft. I want all the right inputs. I think people who make a living at this are good at it. I don't kind of poo-poo their ability to suss these things out. But it's not science. It's predictive data analytics. It's modeling. So if you're the GM of
Oh,
the Warriors, you're going to want to kind of duplicate the Steph Curry model.
in science, and they test their ideas, right? They make predictions and test to see if they're right. They make them on small scales and large scales. And so look, all you can do with science is take the best existing data that you have, the best theory you have, and make predictions. And then you compare those
So
predictions
fair enough.
against and
So
see. And
on
that's what I call science.
fair enough. So I have a lot of people feel very strongly. Climate thing seems to I don't know, somehow strike a chord with people, and I have people who are PhD level scientists that I chat with on a regular basis, play tennis with, and squash and all that kind of stuff. And so it's not in the academy per se, but I've had lots of email exchanges and all that kind of stuff. And I've asked this one thing over and over again. Give me 10. I don't know if you remember the professor. I think it's Julian Simon versus Paul Ehrlich. The bet. You wear the bet, whatever they called it. And I say, this is what I say. I say, look, give me 10 metrics, 10 objects by which I can measure your prediction over the next 5 years, 10 years, whatever you want, and we will do the bet. We will formulate however you like. You can put as many chips in each of these different baskets you want, and you give me things that I can measure so that it's not just Al Gore-ish or Greta's-ish. The end of the world is coming.
We know exactly human industrial carbon output. and we can make very accurate predictions of what the carbon abundance will be in the atmosphere a
Well,
decade.
and then as
I'll
for
be happy to bet you any amount of money that I'll be right.
okay, no, I'm talking about actual climate-ish effects. So I'd like what I've asked over and over again is if we could do the bet, and we could find 10 things or whatever, or over 10 years of things to watch and what are predictions. It's the sea level in
sea level
X
rise
is
of about 9 millimeters per year, between 5 millimeters in the centimeter. It's going up to maybe a centimeter per year. Sea level rise, I think, is a great prediction, and it's
okay. All right. So that would be one. What are the others?
I think the fact, again, a lot of this to separate weather from climate is an important thing. So you can't just ask for what the temperature is going to be tomorrow, but the fact that the Earth's that we could have made a prediction, and we did, that the Earth's temperature would increase by 1 to 1.5 degrees Celsius over the 60-year period between 1960 and 2020 is, again, something that's been validated right on by observation.
Well, again, are those observations accurate? His the heat island effect and all that kind of stuff, and
yeah, they're accurate. I know people talk about they're not being accurate, but they're accurate. I mean, these people, they're not idiots who are doing this. I mean, and they're neither are they people who are saying.
I don't think people are idiots. I think they are real meaning.
I'll get funded more. I've never met a client. These are people who are just trying to take the data, and then we have lots of ways of measuring the temperature, the global temperatures on Earth, and you can look at them. And the reason, look, my book is not about policy. My book on climate change.
I've actually read through it, and I think
here's the data.
I think what you do is you do the physics of climate change, which is all well and good. And I don't think the physics is arguable.
That's policy. And I think the reason I wrote is for maybe people like you, but other people I know who are libertarians and others who said, I just want to know what the science is, and then I don't want to be told what I need to do. And so I said, well, maybe this will appeal to people. Conservatives often reject the science because they know that they're going to be told what to do after the fact. And I thought, well, maybe I can write a book that's palatable to people who might consider themselves conservative or libertarian by just explaining what the best science that we know of, and then saying you use this and make up your own mind. And I know at least one of my friends, Penn Jillette, who's a libertarian, found it useful in that regard. But I was hoping I would appeal to Congress people. We send a copy of the book to everyone in Congress.
So I assume from that, this is my scientific observation, that you're not a conservative.
I don't know. Some people call me conservative now. I don't label myself. I know that many of the causes that I seem to be arguing lately are ones that I've been called a conservative pundit because I write for the Wall Street Journal in the last bunch of years. So I don't know, I never thought of myself as conservative.
We'd have to define what a conservative is anyway. Yeah,
I think I'm a classical liberal.
Yeah, fair enough. I appreciate that. Anybody, again, you have Heather McDonald on twice, so is Heather McDonald a scientist?
No, but she's but some of the things she does are scientific. So the question is, one of the things I like about Heather's books, and one of the reasons I talked to her and have had her on my own podcast a bunch of times, is that there's data. Is that she points out problems and points out data that suggests there are problems, and that's what we would call social science, I guess. But at least I don't like people just talking about things without giving data. And it's not entirely anecdotal either. So in that sense, she's being scientific, but she's not a scientist by training, certainly.
Is Dr. Fauci a scientist?
He's a doctor. I learned, my mother wanted me to be a doctor, so she told me doctors were scientists until I was in high school, when I learned that doctors weren't scientists, and then I no longer wanted to be a doctor, much to her chagrin. So doctors can be scientists, but they don't, doctors have a scientific training, and they're like car mechanics, many of them, in the sense that they could.
I actually like that analogy. I think Dr. Fauci thinks he's a scientist. He actually said he is the science at one point.
Sure. Look, I don't impugn science because of individuals. So science, I have my issues with Fauci, but that I don't. Once again, it's easy to impugn something because you don't like the person who's talking about it. Maybe that
I don't know the guy to like him or dislike him, frankly.
Yeah, or that person may be disingenuous, but it doesn't mean that you condemn the whole thing because some disingenuous individual talks about things. So
you can't throw the baby out with the bathwater.
I think
People
look.
these days might try.
I thought the pandemic should have been a wonderful learning experience to point out that unlike Star Trek, where all technological problems are solved in an hour and a half, that in fact, when you're at forefront of science, when you don't know things, you're playing around in the uncertainty, in the darkness, and you try things, some of which work and some of which don't work, and you point out your uncertainties, and
No,
you say, "We
I
don't know
appreciate
if it's going to work." And I thought it
so.
would have been a great learning experience for science, but it wasn't. It didn't turn out to be that
Well,
way.
to that point, you know, the question would be therapeutics. I mean, Dr. Fauci came to fame initially in the 80s with HIV,
Yeah.
not with HIV, coincident with HIV, and he wanted a vaccine for that, and he was holding out for a vaccine for HIV. And I check my watch; it's something 40x years later, and there's no vaccine for HIV, but there have been therapeutics. So in the course of early 2020 or mid 2020, there were therapeutics being bandied about, and those were basically cut off at the knees. And so there seemed to have been a non-scientific aspect of not experimenting and not watching and observing the results of therapeutics. So I think that's where it veered into policy or the deeper, darker machinations behind it.
Yeah, well, look, anytime you ignore data and usefulness, then you're hurting yourself and the community and science. But and aren't we fortunate that SARS was much easier to develop a vaccine for than HIV, which may or may not be vaccines may not be the relevant solution. I don't know, but I mean, it's still amazing to me that within 2 years we had a vaccine and
Less than that. And no, I think that the apparatus of mRNA tinkering is a reasonable one. I just think it was pushed ahead of the fact. No, mind you, they had the adenovirus formulation in the same time frame. J&J, Janssen, and forget who else had the adenovirus version, and there were other versions of vaccines out within the same time frame. So the fact that the mRNA was out there was not necessary for that instance. It was
actually I found the science of mRNA much more individually much more fascinating to me.
Yeah, I think they used this. They used the the expression, the Alinsky expression. No crisis should be wasted.
Yeah, a crisisity
That's the great philosopher Homer Simpson.
Yeah,
but I think they used that to make a Trojan horse for the mRNA. So they wanted that thing. It had never passed phase 1. It had passed only, but never passed phase 2 or phase 3 trials. And they wanted to use that platform for greater things down the road. And we see this with, what is the star thing they're calling, whatever it is, that Larry Ellison wants to, whatever. But the fact that their mRNA might have some uses down the road doesn't mean we should have experimented on billions of people with that when their adenovirus.
I took 5 or 6 mRNA injections myself, so I guess I did.
Really?
Fine. Yeah.
So what was the science behind that?
Well, I thought I thought it had been demonstrated to be as effective as any other vaccination method, and I found the science behind it compelling. So I decided it was okay.
Well, I'm glad you did. We can do our A/B testing just here. I'm not sure how scientific what the P level will be.
I tried to look for any after effects. I haven't noticed any, but more importantly, my wife hasn't. So that's really the big thing.
Well, that's a wonderful thing. So kind of rounding out the hour here, I appreciate your pushback and discovering, I appreciate discovering your thought pattern and a lot of your facts and so forth. I guess, if you have something you'd like to close with, I'm happy to listen and tell us. You learned in your own journey.
Follow the evidence, test it, be skeptical, test it again, and then discuss it and widely and make your results transparent. Have open discussion, debate, and ultimately, as I say, in a democratic society, an informed electorate is the ultimate arbiter of these. Should be the ultimate arbiter of public policy, but I use the word informed as a key factor. And democracy doesn't work without an informed electorate, and I think that's part of the problem that we have right now. Anyway, I think that's probably a good way to leave it.
All right. So let me ask you before we go, just as a self promo, I like to put up my current book, Overturning Zika, the Pandemic That Never Was. A lot of the fault, I think, with science is sometimes, as Ronald Reagan once said, the problem with liberals is not that they're ignorant. It's just ignorant. It's just that so much of what they think they know is wrong. And I always, go with this term, which is always misused, begging the question. Begging the question, people say, they think it means bringing something else up. So that begs or leads to the next question. But begging the question is a logical fallacy where you're putting into evidence something that is not proven itself. So it's called petitio principii, first principles. And with we've been worried about Zika microcephaly, not here as much, but through the tropical world still, that a single mosquito bite can damage the cherished life within, and people act accordingly, and they've kind of informed the public, in my view, because
My
Zika
wife has malaria. So anyway,
what?
I say my wife has had malaria. So anyway,
Well,
that's,
malaria is an interesting thing. Did you have any thoughts about why Zika microcephaly disappeared? I'm sure it's not top of your
I know. I'm happy to say I don't know enough about it to make any rational, useful comments. You
mind.
obviously studied it, but I try, in spite of the fact that I get asked about everything under the sun once I became well known. I try carefully to not say things about things I don't really know anything about. That's
Nice
one.
choice. My wife's been trying to teach me that with no great success.
I've had yeah. Anyway, I won't go on. But okay. But anyway, good luck on the book, and I enjoyed the discussion, and I think the conversation hopefully will be useful for some people. But
Absolutely, it was a pleasure. I stick with what I say at the beginning. You have boundless curiosity, a lot of energy, and I think you're doing the Lord's work, if there is a Lord, in bringing that information to the populace. Thank you so much.
thank you very much. Yeah, keep up the good work on your own part there as well.